Today we are going to discuss about 8051 branch instruction. It's also known as program flow control instruction. Some of the program control instructions are delay cycle or NOP instructions, jump instruction. Mainly there are three types of jump instruction: long jump, absolute jump and short jump. Then conditional short relative jumps, decrement and conditional jump on 0, and jump after comparison, and call and return instruction. Call instruction to call a routine subroutine, and return instruction is used to return from a subroutine. So what is a program flow instruction? We know that the program are executed in a sequential order. If some instructions are change the program flow from sequential order, that type of instructions are known as program flow instruction. For example, jump, call, reset instructions. Then first type of instructions are delay cycle NOP instruction. So NOP instructions means no operation and just spend one instruction cycle time. That means it does not perform any operation during that time. And next one is jump instruction. There are mainly three types of jump: long jump, absolute jump and short jump. These are classified based on the address. So here long jump means it jump to a 16-bit address. So address location is specified using 16-bit. Jump Absolute jump means jump to address within 2 KB space. So within 2 KB space we can jump. So address is range from this up to from some location to up to 2 KB. And short jump is this jump the address within 128 bytes, so or 8 bits. So from the present address it can jump above or below the 128 bytes. So these are the short jumps. And here it's specified. Long jump is specified by the instruction LJMP. LJMP is long jump and its address is 16-bit address. These instructions are unconditional. There is no condition is specified here. It directly jump to the location without any condition. So here long jump address will be 16-bit. So jump to the next address given by the 2 byte. 2 byte means 16 bit in the instruction. So LJMP 4800 means this is the 16-bit address where the location is specified 4800. Program control is here now. Program control is now here. Then it will, after execution of this instruction, it will be jumped to this location. Then a jump. Here the address is specified by 11 bits. So jump to the next address given by 3 higher bits in the instruction first byte and 8 lower bits in the second byte. So opcode lower 5 bits are 00001 at the first byte of the instruction. So if this instruction a jump containing the machine code like this 0001, then this is first 5 bits, then total 8 bits are there. First byte means total it containing 8 bits. So from out of 3 bits, if 1000, then here 8 bytes. Second byte is 8 bytes. So total 16 including the instruction. Here AJump is represented by this byte, and this 11, 8 plus this 3 bit, total 11 bit. This 11 bit represents the address. So address 11. So jump to the location specified here. AJump means jump to this location specified in this address here. 8 plus 3 bit. 8 is bit, not byte. 8 bit plus 3, that is total 11 bit. 11 bit indicate the address and jump to that location. The next one is short jump, SJMP REL. REL specify the 8-bit address and jump in the range between -128 to +127 from the address of the next instruction, which would have executed in the case of no jump. So it is a short jump. So here specify the 8-bit address and jump to that address location. Another one, JMP at the rate A plus DPTR. We know that DPTR is a 16-bit data pointer and A is the accumulator, and this first add the content in the A and DPTR, and the location at the rate indicate the location or the address specified by this location. The program control will be transferred. So jump to this location. Jump to this location. So jump in the next address given by the addition of 8 bit of A with 16 bit of DPTR. So jump to the location specified with this address. And next one is conditional short relative jumps. So there are different unconditional jump instructions are there and conditional jump instructions are there. Last few minutes we were discussed about the unconditional jump. This portion specify the conditional jump. So based on the condition, the program control transferred to some location. So here JNZREL. Here JNZ. Here REL indicate the relative address. Then jump non-zero. That means if A is non-zero, that is accumulator is non-zero, then accumulator content is a non-zero, then jump to this location specified in the relative address. JZ indicate that if A is accumulator is equal to 0, then jump to this relative address. Next one is JNCREL. C indicate carry. So if non-carry, that is C is not 1, that is if C is equal to 0, that is non-carry, then jump to this relative address location. Then JCREL, that is if carry, jump on carry. That means if carry flag is set to 1, then jump to the relative location. If any previous operation occur and after that addition or subtraction, if the carry flag is set, then jump to the specified location. Then JB bit comma REL. Here the address bit, here addressed bit is set, bit is 1, then jump to the location. If JNB bit comma REL, here jump to this relative address when this bit is non-zero, that is that bit is 0. Then JBC bit C, here jump to this relative address if addressed bit is, here bit is set to 1 and reset the carry, that is C is equal to 0. Reset the carry after the jump. So after the jump, carry will be reset C, and this if the bit is 1, then jump to that address location, and after the jump carry flag will be set to 0. Then next is another one is decrement and conditional jump on 0. Here this is an additional instruction in the 8051. That is, first it decrement the register, then jump, if non-zero, then jump to the relative address. So first step is decrement the first operand. Here first operand is Rn, so register content will be decremented by 1, and check that if Rn is non-zero, that is jump on non-zero. If Rn is non-zero, then jump to this relative address. Then another one is JN said direct or REL. Here direct is the first, decrement the byte in this at the direct address and jump to the location if the direct address is byte is not 0. So first we check that first step is decrement the register, then check that if it is 0 or not 0. If it is not 0, then jump to the location. Or jump to the relative address. Then next one is jump after comparison. So here first take place the comparison, then it will be jump to this location. So here first one is CJNE. So here C means compare. A, the first two operands are compared, that is A and hash data. So if they are not equal, this immediate data and the accumulator content are not equal, then jump to this relative address. So relative address is specified here. If CJNE, comma A, comma hash 10, then here specify the for then here what happened, content in A and hash, if content is 505, then it will be compared, it is not equal. So if it is not equal, NE indicate not equal, jump to this location. The location is specified here, so jump to that location. Then CJNE Rn, comma hash data relative address. Here compare the first two bytes Rn, content in the Rn and hash data, and if not equal, then jump to the location specified in the relative address. Then CJNE A, comma direct relative. Here also compare the byte at the A and direct, and if both are not equal, then jump to this relative address. Then CJNE at the rate RI. So byte from the address pointed by the RI compared with this hash data. If both are not equal, then jump to the location specified in the REL. So these are the jump after comparison instruction. First we compare, and if not equal, then jump to that specified location. And instruction bytes length is 3, and how many cycles are required to complete the execution? It requires 2 cycles. Then another instructions are call routine and return from a routine. If there are 2 instructions, call instruction and return instruction. We can call a 16-bit address or a 2 kilobytes address within the 2 kilobytes. So there are 2 types of call instructions are there, AL call and A call. L call means long call. Long call means here specify the address is 16-bit. Here absolute code, it specify the address is 11-bit. It is same as that of ljump and long jump and absolute jump. Here call to the next address given by the 2 bytes in the instruction. When a subroutine is called, we are called that subroutine. The address program control will be transferred to the address specified here, the 16-bit instruction. And a call instruction, the next address given by 3 bits in the instruction's first byte and 8 bit in the second byte. So total 11 bit is there. Here call, absolute call will be call the location was specified in the address, 11 bit address. Then last one is return. Return to PC saved byte of PCL and PCH from the stack. Here return instruction is used to return from a subroutine. Return from subroutine. So we know that after completing the execution of subroutine, it will be returned to the main program. So before returning from the main program, the stack containing the saved program counter data or program counter address. So that counter address will be loaded into the stack containing the program counter details, that will be loaded to the program counter and returned to the main program. And this is the example of a lcall instruction. We already said that the lcall containing 16-bit address. Here lcall opcode is here 001001, that is represents lcall opcode address, and 16-bit address is here. This is the upper byte 00 and 48 is the lower byte. So this instruction is lcall 0048H. So it will jump, program control will be transferred to this instruction location 0048. So during this execution of this instruction, first we will, before program control is transferred to this address location, it will save the current program counter value to the stack, and stack pointer is incremented by 2. Then call this address, call or program control is transferred to 0048. So this will be loaded to the PC. Then program will be control will be transferred to this location. And another instruction is return from the interrupt. Here operation of return from interrupt, first step is restore the PC, decrement SP by 2. So stack pointer contain return from the interrupt. After execution of the interrupt service routine, it will be returned to the main program. So before returning it, first stack pointer is decremented by 2 and the content is stored in that, will be stored in the program counter. This program counter containing the address of the main program, and check interrupt sources pending and call another unmasked interrupt service as per priority. So if then check that if any interrupt is pending, if it has the higher priority, then it will be executed. Otherwise it will be there is no pending interrupt, then it restore this PC value from the stack and program control is transferred to the main program. So this is return from the interrupts. These are the example of program control instructions or branching instruction of 8051.